This is Engage New York, Module 4, Lesson 1. Read the objective with me while I read it out loud. I can measure and compare pencil lengths to the nearest half, quarter, and eighth of an inch and analyze the data through line plots. Line plots. Line plots look like where they have data, where you're stating data, marking data on a line. That's what a line plot looks like. Okay, so we're going to go ahead and begin with our fluency practice. Our fluency is going to be able to compare fractions. So what part of the fraction is shaded, you're going to write that fraction down. What part of the fraction is shaded, write your fraction down, and here's a line here. Then, what is this fraction? So 1/2, and you're going to compare. So you're going to have to use greater than, less than, or equal to. Now, in order to compare two fractions, it's easier if they have the same denominator. So if you wanted to, you could go times 4, and now you could see which fraction is actually larger. So if you did that on each one, you created a common denominator, then compared them, that's going to make your life a whole lot easier. Then on the back, you are going to decompose fractions. So we're going to use this word number bond, and it looks like this. So if I start with the fraction 2/3, I know that if I pulled 2/3 apart, 2/3 is really made up of 1/3 plus 1/3. So 2/3 is made up of 1/3 plus 1/3 is equal to what? 2/3. And then 2 times 1/3 is equal to. So do you kind of get the idea here? You're going to pull it apart and then give me an addition sentence and then give me a multiplication sentence. And then we have equivalent fractions. So remember, the easiest way to create an equivalent fraction is to multiply by 2. And then 1/2 is, what is this fraction? Well, it could be a whole host of different things. So you're going to go ahead and fill this in. How do we make equivalent fractions again? And you're going to write it down with words. And then our application problem, we're going to come back as soon as we finish. I'm going to give you about 10 minutes to work through these couple of areas, and then we're going to come back and discuss the application problem together. All right, go ahead and get started. All right, so what part is shaded? Well, 1/2 of this whole is shaded, correct? You could write it like this. You could write it like this. Okay. Then we have what part of this is shaded? Well, 1/4 of this whole is shaded, right? You could write it like this. You could also write it like this in word form or unit form. All right, what is this fraction? Well, that was 1/4. So 1/2 is going to be greater than 1/4. So if you had half, so half is definitely greater. Half is definitely greater than 1/4, correct? All right, so now let's come down here. And yes, you could use the butterfly method, but this I think is very effective. So if you try to create a like unit, and I know this is my common denominator is going to be 8. So if I multiply this side by 4, top and bottom, I'm going to end up with a denominator of 8 and a numerator of 4, and 4/8 is definitely going to be greater than 1/8. 1/8 is smaller than 1/4. 1/2 is greater than 1/3. 1/3 is greater than 1/4. 2/4 is equal to 3/6. 3/4 is greater than 3/8. because this is going to be 6/8, and 6/8 is greater than 3/8. 2/5 is less than 2/3. So I created a common denominator. I went, okay, that's going to be 6 and that's going to be 10. So I know 10/15 is going to be greater than 6/15. And then I have 12/40 and 15/40. So 15/40 is going to be greater. To see how I'm doing that? And then lastly, 2/3 is equal to 6/9. Now, decomposing fractions using the vocabulary word, a number bond. So 2/3, so 1/3 plus 1/3 is equal to 1/3 plus 1/3 is equal to 2/3. 2 times 1/3 is 2/3. Over here, 2/5 is made up of 1/5 plus 1/5, which is 1/5 plus 1/5, or 2 times 1/5. Then 3/4 is made of 1/4 plus 1/4 plus 1/4. 1/4 plus 1/4 plus 1/4 is equal to 3 times 1/4. Then 3/8, 1/8 plus 1/8 plus 1/8 is equal to 1/8 plus 1/8 plus 1/8, or 3 times 1/8. Then down below are equivalent fractions. So what is this fraction? This fraction is 1/2. So 1/2, if I multiply the top and bottom by 2, I get 2/4. And that's the same thing I'm going to do here. 1/2, if I multiply, if they gave me 2 over here, I have to, what times 1 is going to give me 2? Whatever I do on the top, I do on the bottom. So 2/4. Then I have 2/5, and I'm trying to get, I know the numerator over here has to be 8. So what am I going to multiply 2 by to get 8? Well, I'm going to multiply it by 4. At whatever I do to the top, I do to the bottom, and I end up with 8/20. Then I have 1/5, and I'm trying to find, this is the equivalent fraction, 2/10. What am I going to multiply 1 by to get 2? Well, I'm going to multiply it by 2. Whatever I do to the top, I do to the bottom, and that gives me 2/10. Then I have 3/4, and my equivalent fraction I know is 9 on top. So 3 times something is going to give me 9. Well, 3 times 3 is 9. Whatever I do to the top, I do to the bottom, and that's how I get my denominator. The same here, 4/5. They gave me the numerator of 16. 4 times something equals 16. Well, 4 times 4 is 16. Whatever I do to the top, I do to the bottom. 5 times 4 is 20. Then, how do we make equivalent fractions again? When you make an equivalent fraction, it's easiest to multiply the top and bottom by 2, right? Easiest way. All right, let's go to our application problem, because this problem is going to require a little thought here. So our application problem, bean growth during week 2. So look at this graph or this ruler, if you will. And this is a line plot. I've plotted data on this chart. So it looks like I have, this is on the ruler. Here's 1, here's 2, here's the number 3. Then I have 2 pieces of data sitting on the 2. I have 2 pieces of data sitting right next to it. I have 2 pieces of data here, 1 piece of data here, and 1 piece of data here. So those are numbers. What do you think we should do to help understand where these numbers sit on this ruler? What can we do? So you're going to actually have to count and decide how many pieces are in one whole, correct? So let's just count this. 1, 2, 3, 4, 5, 6, 7, 8, right? So if this is 0 over 8, this is 1/8, this is 2/8, this is 3/8, this is 4/8, this is 5/8, this is 6/8, whoops, This is 7/8. And this is what? 8/8, right? Okay. So if you want to break this up, so 1 1/8, 1 2/8, 1 3/8, 1 4/8, 1 5/8, 1 6/8, 1 7/8, 1 8/8 gives us what? 2. So then we have 2 1/8, 2 2/8. So do you see how the pattern just continues, right? Okay. So 2/8, 3/8, 4/8. So 2 4/8, 2 5/8, 6/8, 7/8, 2 7/8. So now I have all of my data actually labeled. So now that I have my data labeled, now I can actually try to answer the questions. So using the graphic, this is considered a graphic or a line plot, above, answer questions A through D. So what is the measurement of the shortest plant? The shortest plant. How many plants measure 2.5 inches? What is the measurement of the tallest plant? What is the difference between the longest and the shortest measurements? I want you guys to try to do this independently now, and I'm going to give you 3 minutes, and then we'll come back and debrief, okay? We'll go over it. Okay, so what is the measurement of the shortest plant? Well, the measurement of the shortest plant is short, right? The shortest plant is 1 6/8. But if you are savvy, you're going to see that 2 times 3 is hiding inside of there, and 2 times 4 is hiding inside there. And you're going to cancel those out because that's like a 1, and your answer should be 1 3/4. All right. How many plants measure 2.5 inches? So up here, where is 2.5? How many plants measure 2.5? 2 plants. All right. What is the measure of the tallest plant? So where is the tallest plant? What is that? It is 2 7/8. We don't know if those are inches or centimeters. Then what is the difference between the longest and the shortest? So I have to take the longest and subtract it from the shortest, right? And that is 2 7/8. Subtract 1 6/8. 7 subtract 6 is 1/8. 2 subtract 1 is 1. So 1 1/8. How did you guys do on that? All right. Now my question for you is, can you identify and label the marks on a ruler? Can you label and identify the marks on a ruler? So if we look really close, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this one right here is broken up into 16ths. And then if you decide to just break, so you can break this one all the way down to 16ths, or you can break it down into fourths, 1/4, 2/4, 3/4, 4/4, right? Okay, now what I'm going to have you do next is I gave you a sheet. I gave you that little orange sheet of paper, correct? Okay, so what I'm going to ask you to do is I want you to take your pencil. I want you to take your pencil and put it on the paper. And then what I want you to do is I want you to kind of put your thumb where it is, and I want you to tear it off. Measure it and tear it. So you're kind of measuring the length of your pencil, and everyone's pencil is going to be a different length. Okay? So if you turn your page from your class notes, you end up with, here's a ruler, here's a line plot. Here's a ruler, here's a line plot, here's a ruler, here's a line plot. Now, what I want you to do is also take out your problem set. Now, what I want you to do without actually measuring your pencil, I want you to estimate the length of your pencil to the nearest inch. Like, so do you think it's about 8 inches? Do you think it's about 6 inches? Okay, you're going to estimate and just write it. Just give me an estimate of what you think, how long your what? Okay. Okay. Now, you're just going to give me your best guess. Best guess. How many people have written down an estimate right now? Raise your hand if you've written down an estimate. Okay. Now, I want you to use, it says here, using a ruler, measure your pencil strip, the strip that I gave you and you just tore, measure your pencil strip to the nearest ½ inch. So remember, can you find a ½ inch on your ruler? Can you find it? Okay, ½ inch, ½ inch, ½ inch, ½ inch to its nearest ½ inch. But remember what I've taught you about rounding. If it goes over the halfway mark, you have to round up. Okay? But if it's below, you can round down, or you can just, if it's really close, you can keep it to the ½ inch. So go ahead and do that right now. And then put a mark. Well, I guess you could just use this ruler that's on the page. Use your ruler on the page and measure it to its nearest ½ inch. Put an X above where your pencil measures. Put an X above where it measures. All right, so now we're going to construct a line plot of everyone's pencil measurements. So go ahead and draw this on your paper. All right. And then in between here are little halves, right? So go ahead and draw that on your paper. So we drew, I mean, you could make it as long as the ruler. That's totally fine. I didn't. Now, what I'm going to do is I'm going to go around the class and ask you for your measurement. And then as you hear people say their measurement, you're going to do a mark. You're going to make an X above that measurement. And then we're going to see what is the most common measurement. What is the smallest pencil length? What is the greatest pencil length? What is the pencil length that everybody is most common in the class? Got it? Okay, let's do it. So from here, we could answer all kinds of questions. What is the greatest measurement in the class? What is the most? All right, now we're going to use this ruler here to measure your pencil strip, or measure your pencil or your pencil strip, because they should match, to the nearest ½ inch. So remember, So we're breaking it now into quarters. So it'd be 1 quarter, 2 quarters, 3 quarters, right? And then we'll come back and we'll do the same thing that we did here. Then we'll do it to the nearest eighth of an inch. And then we'll construct another line plot. Go ahead and measure and put in X, measure, put in X, and then we'll come back and make our line plot. Okay, go, go. All right, so now we're gonna draw a line plot, and I'll take up all the space. Here's 4, here's 8, here's 0, and now here's 1, 2, 3, here's 5, 6, 7. So I guess we could just make this into a line plot if we really wanted to, but I'm actually drawing it out. All right, so now within each one, there's going to be 4 marks. There's going to be 3 marks, right, and 4 spaces. So knowing how to divide this up is working with our division skills and our multiplication skills all at the same time. All right, so now based on this data up here, let's think about this down here. All right, so I'm going to go through and ask everyone if what quarter inch that they're closest to, okay? All right, so now we have another set of data. We have 5 3/4, 7 1/4. We have 8, 8 1/4, 8 2/4, or 8 1/2. All right, we're going to take that same idea again, and we're going to use our pencil strip to measure to the nearest eighth. So now we're getting really, really precise on our measurement, right? Okay, so go ahead and measure and put a mark on yours. And then I guess this next time we could just use the ruler as our line plot. Okay, ready, go. I'll give you 1 second. All right, so now instead of constructing a line plot on separately, I'm just going to use this ruler as my line plot. Okay, so I'm going to go through and I'm going to ask everybody again, closest to the nearest eighth. And all right, so now we have another set of data. So now with our set of data, which is different than this data, we're just becoming more and more precise. So now let's turn the page and go to the back side. All right, use all 3 of your line plots to complete the following. Compare the 3 line plots and write 1 sentence that describes how the line plots are alike, and 1 sentence to tell me how they are different. So let's kind of do this together, shall we? All 3 line plots are similar. So you're writing this down because they all 3 All right, so what is the difference between the measurements of the longest and the shortest pencil on each of the 3 line plots? So line plot A, line plot B, line plot C. You're going to go grab the largest fraction, the smallest fraction, and subtract. Largest, smallest, subtract, largest, smallest, subtract. And then write a sentence describing how you could create a more precise ruler to measure your pencil strip. So let me help you with this. So in order to create a more precise ruler or measurement, You must use the smallest measurement possible. For instance, like 1/8 or 1/16 of an inch, or even centimeters or millimeters. So the big idea is the smaller the unit of measurement, the more accurate your measurement becomes. I'll write it way down here. That's the big idea of this lesson. In order to create a more precise ruler or measurement, you must use the smallest measurement possible. For instance, 1/8 or 1/16 of an inch. Big idea, the smaller the unit of measurement, the more accurate your measurement becomes. All right, so that will do it for concept development and problem set for lesson 1, module 4, lesson 1.